So a sample of solid ethanoic acid. There's a formula. So diethanoate, diethanoic acid has been contaminated with potassium ethandioate, and immediately, as soon as I'm sort of seeing this X, I think they're most likely going to ask me what this X is. But anyway, let's continue. A 1.78 grams of sample of this mixture was made up to a 250 centimeters cube solution with distilled water in a volumetric flask. Now, for those of you who know me and who I've been teaching, you know I love my storyboards. I like to visualize what happens. So what I'm going to start doing is I'm going to start drawing the method. So this is what's called storyboarding. So the steps in this experiment. So 1.78 grams in a volumetric flask. So there's my volumetric flask. Yeah, I'm not pretending to be a sort of an artist. So please don't mind my drawings. But there's my volumetric flask, and there's 1.78 grams of this mixture, and that mixture contains H2C2O4.2 waters of crystallization, and then also the salt, which is K2C2O4 H2O. And then what happens? Oh, and this is a 250 centimeters cubed, so 250 centimeters cubed made up. And then they said a 25 centimeters cubed sample was titrated against 0.1 molar sodium hydroxide. So what I'm going to do is I'm going to have my burette, and then I'm going to have my flask. And they said they took 25 centimeters cubed of this. So 25 centimeters cubed of this mixture. Now, so 25 centimeters cubed of this mixture, and what they titrate against? They titrate against sodium hydroxide, and it was 0.1 molar. I know it's like 3 decimal places, for but never mind. I'll deal with that later. I do have it in my mind though, so I will have to deal with it later. So that's molar, and then and how much of this did it need? So it needed 17.35. So 17.35 centimeters cubed. So they titrated that. And then they said another 25 centimeters cubed sample was acidified with sulfuric acid and titrated against potassium permanganate. So that means, and required that much, so that means there was a second titration. So they took a second titration, and in this titration, they did it with potassium manganate. Okay, so, and that was 0.02 molar to 3 sig fig, and I know it's 3 sig fig. I know I've not written it, but anyway. And then what was happened? Finished my drawing. So they took another 25 centimeters cubed of that, and they titrated it against 0.2 molar, and what they found was that it was 24.85 centimeters cubed, which was needed. Okay, and then they say calculate X. Right, so 2 titrations. So the first thing I'm thinking, and remember this walkthrough, my whole point is to show you what I think, what I'm thinking about as I'm doing the question. You might see this that I've written, immediately I had written there are 2 titrations going on. Yeah, so there must be a reason for that. So what must this be? So obviously what's happening is that this must be a simple base and an acid. So this base must be reacting with an acid. So out of that, this titration is making it react with the acid part. So that's probably what's going to be reacting in this titration. And here, potassium permanganate, what they're probably doing is, now manganate is an oxidizing agent, we know that. So what that means is there must be oxidizing something, right? And that means that there must be oxidizing probably both of these, okay? But if you know how much acid there is from here, you'll know how much acid there is. So whatever results, the oxidation results you get from here, you'll know that that's oxidizing both, but you know out of that how much is the acid. So the remainder must be the actual salt. Okay, so let's do this. Okay, so the first thing I need to do is the acid-base titration. Let's deal with that titration, right? So this is the acid-base titration. And of course, this is we're using this to find the moles of, and I'm going to put this down so we know, so we have it in our head. Okay, so again, I'm not going to go into sort of explaining everything. I'm hoping that you know the basics, yeah? So the moles of NaOH, yeah? So the moles of NaOH is number of moles equals CV over 1,000. Yes, some people might remember it as, you know, CV, but I'm going to remember as CV over 1,000. Remember, it's all to do with the volume. So CV over 1,000, so the concentration is 0.1 molar times by volume. They've used as 17.35, and then divide that by over 1,000 because our volume was in centimeters cubed. And so, and I don't know if you can see here, I think you can probably just see that. So the number of moles, 0.1 times 17.35 divided by 1,000, if I work it out, it comes to 0.001735. Okay, and that is the number of moles of sodium hydroxide. Now I know that if there is number of moles of, that is the number of sodium hydroxide, number of moles of sodium hydroxide. Therefore, I know, look, sodium hydroxide reacts with that. Number of moles of sodium hydroxide is that much. But I know from the equation, look at that, that's a diethanoic acid. Every 2 of these I need for 1 of these. So if there's that many moles of sodium hydroxide, I need half as much diethanoic acid to react with it, because every 1 of these gives me 2 hydrogens to react with 1 of these. So 2 of these and 1 of these. So if this is 1, I need to halve it to get my H2C2O4. So the moles of diethanoic acid will be 0.001735 divided by 2. That's the number of moles of diethanoic acid in this 25 centimeters cubed. So the question is, this is only 25 centimeters cubed. So therefore, how much is in 250 centimeters cubed? So therefore, in 250 centimeters cubed, I will have moles of H2C2O4 dot 2H2O. I will have 0.001735 divided by 2, that's that, and then multiply it by, well, the difference between that and that is 10 times. So going backwards is times 10. So I need to multiply that by 10, and that will give me number of moles of that in 250 centimeters cubed. So that comes to 0.008. So this is 8.675. Start writing in standard form, 8.675 times by 10 to the minus 3 moles. Now, remember, they've given me 3 sig figs everywhere, and that's 4 sig fig there, but they've given me 3 sig fig, 3 sig fig, etc. So minimum I'm going to have is 3 sig fig, right? So 1, 2, 3, but I'm going to go 1 more. All right, so 4 sig fig is there, isn't it? Yeah, here. So I might as well go up to 4 sig fig. That's the minimum I think I need, or greater, but that's the minimum, 4 sig fig. So anyway, so I'm going to go to 4 sig fig. So this is the moles of 250 centimeters cubed, moles of that in 250. Okay, so that's that done. Now we come to the second titration. In the second titration, the redox titration, it gives me total moles. So when I do this titration with that, it'll give me total moles of both the H2C2O4, because remember, it is oxidizing, and I hope you do know the oxidation equation of the diethanoic acid. So how does the permanganate oxidize that? But that's a separate matter. That's a separate subject. Remember, the moles that this titration will give me is that plus that, because that manganate will oxidize both of these things. All right. Okay, so let's do the same thing with this to find out. So moles of, so that's that done. Moles of KMNO4, remember, start with the thing that you know, the known. that and that. So it's CV over 1,000, so 0.02 times by 24.85 divided by 1,000. Hope you can still see that. And then, of course, that gives me that's 4.97 times 10 to the minus 4, and that is moles of KMnO4. Now we know from the equation that if this is the case, right, so now we need to think about it. How is this going to react with these? And for that, you need to think about the equation, and that's what you need to do now. The equation you'd get is probably, and you will need to work it out from scratch. You need to be able to do that, but I'm not going to do that now. But you can do it later. You can use the half equations to work out the overall equation. MnO4 minus plus 16 hydrogens plus 5 C2O4, 2 minuses, and then of course I don't even need all the rest of the equation, but anyway, that's that. But I will probably put it down anyway so that you know it. But please make sure you do know how to work this out. And then of course there's 10 carbon dioxides. Okay, so what I can see is the ratio of manganate to ethanoate is 2 to 5. So if I've got 4.975 times 10 to the minus 4 moles of that, okay, so I need to divide that by 2, times by 5, and then of course that many diethanoate ions I have. So let's work this out and let's see what happens. Moles of diethanoate ions, yeah, not diethanoic acid or diethanoate, salt, ethanoate salt. No, it's the diethanoate ions that I've got, because that's the thing that manganate oxidizes. Anyway, so moles of that equals 1.2425 times 10 to the minus 3 moles. Okay, so that is 1.2425. So I could have rounded this down to like 4 sig fig, 1.243 times. Yeah, so I might as well do that, times by 10 to the minus 3 moles. Okay, that's ethanoate ions. Now that I've got that again is in 25 centimeters cubed. I need to know how many in the actual original 250. So again, I've got to multiply by 10. So therefore, moles, I'm going out of the screenshot, but anyway, therefore moles equal in 250 centimeters cubed equals, and of course, what is that moles of? That's the moles of ethanoate ion, the total ethanoate ions, yeah, which equals, so that times by 10. So 1.243 times 10 to the minus 3 times by 10, which equals 1.243 times 10 to the minus 2 moles. Yeah, so that's in 250. Now remember this though, this many moles that we've found, that's for all of them, but we know how many of this, how many moles of diethanoic acid are in that original solution. I need to take that, the moles of diethanoic acid, from the total moles of the diethanoate ions. So what I do is, and that'll give me the moles of ethanoate, the ethanoic salt, right? So what I'm going to do is I'm going to say N of K2C2O4, and of course this water, X, which is what we're trying to find, is equal to the total moles of both of them together minus the moles of the H2, minus moles of H2C2O4 dot 2H2O, and that is equal to 1.243 times 10 to the minus 3 minus that moles, which is 8.675 times 10 to the minus 3, which equals 3.755, still 4 sig fig, which is fine, minus 3. So that's the moles of diethanoic acid salt. Okay, and that's that. Okay, so now what do you do? Well, remember, now what you do is this is the moles in there, in the whole, in the actual 250 centimeters cubed. But what you need to do is you need to find, well, how much of mass is there? So mass of each of these I need to find. Okay, so the mass of each of these, because remember, I've got the total mass, but I don't know how much mass, how much of that total mass is the diethanoic acid, and how much of that total mass is the actual salt. Okay, so I need to find the mass separately. So I'm probably going to have to start a new sheet, but anyway, so mass of each of them, right? Remember that. So mass of H2C2O4.2H2O, and of course, number of moles equals mass divided by MR. Mass divided by MR, so it's mass equals Mr. Moles, isn't it? It's the MR, if you work it out, and I'm not going to do it, but you can work it out, it's 126.0 times by moles. We already know of the ethanoic acid, moles is 8.675, yeah, times 10 to the minus 3. That will give me 3. Here, 1.093 grams. Okay, now I can, I suppose, so if that is the mass of ethanoic acid, then whatever the remainder mass is out of that 1.78 must be the salt. Okay, so what I'm going to do is, rather than working out again Mr. Moles, all I'm going to do is K2C2O4 equal X water equals 1.78 grams. That was the total mass that they used originally, minus 1.093, which is the mass of the acid, diacid, and that gives me 0.687. So 0.687 grams. What is that? Remember what the question was. The question was calculate the X. Okay, so remember what that is now. Now we're here. I've got the mass of that, yeah, and all I need to do now is I'm to think, okay, hold on a second. So if MR, so what is the MR? The MR would, of all of that, the mass of all of that, you know, the MR, right, would be MR equal number of moles equals mass divided by MR. So mass over number of moles. So mass over number of moles would be 0.687, which we just worked out, grams, divided by moles. We already know what the moles is. We worked it out. The moles of the salt was 3.755 times 10 to the minus 3. So 3.755 times 10 to the minus 3, so which equals, and that is 183, well, 82.96, yeah, 2.96. Okay, so that's the MR of all of it. So K2, you see K2 C2O4.X waters. So this mass includes waters. 96. Now I know I can work it out what the mass of this is. That MR of K2, that is 166.2. Okay, so if I just say, well, 166.2 plus however many waters, 18, we know water's 18, but we don't know how many 18s there are, equals, that must equal to that mass over there, 182.96. So 18x equals 182.96 minus 166.2, which equals Yep, 16.76, 16.76, and of course, therefore x equals 16.76 divided by 18 equals, well, approximately 1, isn't it? Yeah, 0.9, which is approximately equals 1. So there is only one water that's 0.9. So there is, so the nearest integer, yeah, is 1. Okay, so that means they said calculate x. Well, x equal, therefore, x equals 1. And therefore, that formula, this formula here, the formula of the salt would be, they've not asked you to do this, but obviously you need to understand that is there. Anyway, so this is how you do these kind of questions. But what I want to highlight to you is, look, because I did some storyboarding, yeah, I knew how to keep these two separate, calculations separate. And then, of course, because I kept referring back to what I worked out before, I knew how to proceed. Okay. If you don't have that, I don't understand how. I mean, some people might be able to do it, but I don't. But if you don't draw that for you, once you've done one titration, you got to keep in your head that you got to do the other titration. So you tend to lose where you are and what you're trying to do. Anyway, so this is, I hope, is giving you an idea of how to do these kind of redox calculations. Okay. How many marks? This is probably going to have at least 6 or 7 maybe marks. Hold on, actually, let's just see. So there's probably going to be 2 or 3 here. There's probably going to be 3. So 1 maybe, yeah, 2. Yeah, so 3 marks there, because we've got to remember you've got to say 2 to 1. So 3 marks there. And then, of course, they might ask you to do that as well. So maybe, yes, I'm looking at least 7 or 8 marks on this, all of these calculations. Anyway, you think you know, but you won't know until you actually try these yourself, okay? So take my word for it. Find some redox titration calculations. And the reason, by the way, why it was called a redox titration is because of the second titration. That's why I was in the redox section, because that is a redox titration. All right. Okay. Well, give it a go. Thank you.